Okay, hello class. Hope everybody's having a good morning, or it's afternoon now, isn't it? So, feels like spring out there right now, but it's not spring. It's fall. It's supposed to be getting cooler, so I guess we're going to get cooler weather. So, I had to clean my glasses here. So, all right. I thought today we would start chapter 11. Okay, so we've kind of thoroughly beat the topic of pure competition in the walls, so I thought we'd go to pure monopoly today, the other extreme as far as market structures go. Your book kind of outlines 4 different market structures. These are kind of posts, if you will, along a continuum. It's kind of like looking at a rainbow, though. You know, where does red become orange? Where does orange become yellow? Sometimes it's kind of hard to draw a line, okay? So you kind of blend from one to the other. And so that's the case with market structure. When the book talks about pure anything, you realize there's probably no such thing in the world exactly. So pure competition, these aspects of pure competition we talked about, that there's a standardized product and everybody's a price taker, at least suppliers are price takers and so forth. Those are, you know, kind of an idealization, I guess, of how the world might work in some respects, or part of the world might work. But, you know, really, that's kind of hard to find a situation where all the producers in any market are price takers, okay? Usually have a little bit of control over the price and so forth. So at any rate, it's an abstraction of how the world works. Each of these market structures are, and so they're worth studying because they get us a little closer to how the world actually does work. So we're going to go from one extreme to the other. We've been in Perfect Competition. Chapter 11 deals with pure or perfect monopoly. So that's where we're going to go today. I think I'll go to the PowerPoint slides here, and we'll look at some topics in Chapter 11 today. I'll, on occasion, go to the .cam. So we're going to talk about monopoly. As you probably can envision what a monopoly is, there's only one supplier, typically, or only one producer. And so that's kind of this. Did I say .cam? I'm sorry, Radar. I meant PowerPoint. We'll go to the PowerPoint. I think I said document camera. I did, didn't I? Sorry. So you have only one supplier, okay? So with pure monopoly, only one supplier. We'll talk about close monopolies later, but with pure monopoly, one supplier. There's barriers to entry that protect the position of the supplier. And so as such, a monopoly faces a demand curve that's different than that which faces or confronts that of perfect competition. That third topic there, monopoly demand, that's a very important bullet here. What we mean here is that you recall for perfect competition, say there was a dichotomy. We drew a difference or distinction between the market demand curve and the individual demand curve. Remember that? So you know what a market demand curve looks like. What's the individual demand curve look like in perfect competition? Yeah, that's right. It's a horizontal line, isn't it? Okay, a market demand is a downward sloping, but an individual demand curve, the curve that faces an individual supplier in perfect competition, is perfectly elastic. So it's a horizontal line in that space between price and quantity. Well, that's not true with monopoly, and this is going to really create some distinctions or differences here between the two market structures, because you don't have many suppliers, you have only one. And so the market demand curve is the individual demand curve. It doubles for both. Okay, so you want to kind of nail that down right at the outset here, because that's going to, let me go back, that's going to make a difference in how we determine optimal output and price, how we quantify the economic effects of monopoly. And then we'll get into these last two topics, I hope today, but maybe not. Talk about price discrimination and regulated monopoly. Okay, so pure monopoly, what is this? Single seller, sole producer. Okay. There's no close substitutes. Actually, a pure monopoly, there's no substitutes, okay? So, you know, Bayer aspirin, back there, I don't know if they still are the only producer, Cipro or not, but if you get anthrax or something like that and you need Cipro, you're going to buy it ultimately from the Bayer company, okay? So, you know, they have a monopoly. If you come up with a new pharmaceutical, get a patent for it, a new drug or something, you have a monopoly, at least for a period of time. We'll talk a little bit about that in more depth later, but say a patent, if you're a patent holder, you typically have, in the United States anyway, a 20-year license to be the sole producer or you're the gatekeeper, so you might allow somebody else to produce, but you're the one who has exclusive rights. So you're a monopoly. Now, so there's no close substitutes, unique products. So that makes you a price maker, not a price taker, but a price maker. You have control over the price. And you're able to block the entry of competitors. You know, I talk about this a lot. Grew up in a small town, Oklahoma, had one grocery store in town. There were strong barriers to entry in the grocery business in that town because it was low middle class neighborhoods in town and so forth. Not very many neighborhoods really, but you know, it takes a fair amount of capital to start a grocery store. So that in itself was a barrier to entry, just the investment required to get into that. And so only one store, only one investor had already ponied up the money, the capital, to be in that industry. You have a lot of non-price competition that establishes monopolies. I'm going to come back to that, so I'm just going to skip over that for a minute. Here's some examples of monopolies. Public utility companies are monopolies typically, okay? The natural gas company. So here in Oklahoma we have ONG, right? Oklahoma Natural Gas, that's a monopoly. Electric is Oklahoma Gas and Electric, OG&E. They're monopolies, these public utility companies. Your cable TV, a lot of times. Now this, I realize the market's changing here, but for a long time cable TV kind of had a monopoly, at least in my neck of the woods. There was only one company that ran their programming along that fiber or whatever it was they had laid out there near our house. So cable television is kind of a monopoly. Near monopolies, I meant to kind of change Androids, I don't know. Intel, you know, makes computer chips and so forth. There, you may get like NVIDIA and so forth, some of these companies that have rivals, but for the most part, they may claim 90% of the market share. I guess instead of Android, maybe, what am I thinking? iPhones and what have you. But professional sports teams also. Let me say something about this. Okay, we'll come back to near monopolies when we talk about oligopolies, duopolies, and so forth. So a duopoly would have two major players, right? I've never heard of a triopoly. I guess there could be. I've heard of a, I don't know. At any rate, you know, you might have 4 or 5 that dominate and then a whole bunch of little players. But this professional sports teams for a moment, let me talk about that just a second. We talk about, you know, an NFL franchise as being a monopoly in a certain city or venue. Actually, they're not the sole, I guess they're the sole supplier of football entertainment, but they're also the sole buyer of football talent. So if you go to the Kansas City Chiefs, there's only one big league professional team buying professional football players' services. It's Kansas City Chiefs. And when you have one buyer, so we're not talking about one seller, we're talking about one buyer. What you have there is what's called a monopsony. Okay, monop, M-O-N-O-P, sony, S-O-N-Y. So just kind of for your edification, you may have heard of a monopsony. This is the single buyer situation. Okay, so we have barriers to entry that establishes a monopoly in the first place. As it says here, they're factors that prevent firms from entering the industry. Okay, so we're going to kind of go through these just a little bit here, and then we're going to look at some graphical descriptions of a monopoly and the market in which they participate. So economies of scale is first barrier to entry. Okay, does anyone think they can just start competing with Walmart today? It's not going to happen. You may get your best friends together, your wealthiest friends together. It's kind of hard to go in to competition with Walmart. Now, Walmart in big box retail, you might call that a near monopoly. I mean, there's some others, that kind of compete in that space. But gosh, they have a lot of market share, and they are a big company to begin with. Their revenue, the top line on their income statement's really high, okay? Really big number, $500 billion a year or something like that. It's a phenomenal number. I forget, don't quote me on that. Okay, I haven't looked at Walmart's financials in a while. I haven't thought about it. But at any rate, big box retail like that and so forth is characterized today by huge economies of scale. Now, what do we mean by that? We've talked about that before. What we have is a situation like this, is there is up front a big, huge fixed cost investment. If you want to compete with Walmart today, you've got to make a big upfront investment before you get started selling anything. You think about what Walmart has in place, the infrastructure they have out there with their distribution centers. Has everybody seen the distribution center south of Bartlesville? You've driven by? That thing's huge. I haven't been up there in a while, but I figured at one time, I don't know if it still is, but that's maybe the biggest building in Oklahoma, or one of the biggest buildings. That's just one of their distribution centers. And they have a network too in monitoring and managing their inventory so that, when you scan an item and say you can be the scanner today, right? Self-checkout, but when someone scans an item in a store in Muskogee, Oklahoma, I guess that's immediately conveyed in Bentonville headquarters. That's my understanding. So there's this infrastructure that manages and monitors inventories, and they have trucking fleets and just all kinds of things to put that car battery on the shelf at $40 for one of those things instead of $60 at the hardware store or automotive store. And there's still automotive stores around, but at the automotive store that used to be down the street. But when Walmart came to town, they put a lot of these shops out of business. This is economies of scale. When you have a huge fixed cost investment that you ultimately spread out over many units of output. And what you see is that the average total cost function then is a decreasing. I don't know if you see my arrow here or not, but going from left to right. The average total cost curve is a decreasing function of plant size or firm size. Now we got quantity here, but remember we use quantity of output kind of as a proxy for the size of the business or the firm itself. So Walmart's huge. It's a huge company. So we can, maybe it's easier to think about a firm that has kind of a standard unit of output. So an automobile plant or Ford Automobile Company, and it has several plants, but you think of a typical automobile, and so many automobiles will, in a year output, will tell you something about the size of the plant you're talking about. So we use quantity here, and as the plant gets bigger, quantity is a proxy for plant size. As the plant or firm gets bigger, average total cost goes down. Why is that? Because you got this big fixed cost that when you start producing more units of output, and you have to spread that fixed cost over units of output, then of course that fixed cost per unit of output, that fraction is going to go down when you make the denominator larger, okay, when you spread it over more and more units. Now, not every industry involves a huge fixed cost, right? At the other extreme, I keep talking about this, but screen printing, T-shirts, or about any business in your small hometown, if you're from a small town like me, there may be some significant fixed cost involved in getting a hardware store going, or a beauty shop going, all right, a barber shop going, a law firm going, these things, but not that much, okay? And so you don't typically have economies of scale very pronounced, in small town businesses. But when you get on the level of large corporations, petroleum companies, large manufacturing companies, pharmaceutical companies, and so forth. You have huge economies of scale. This initial upfront investment may not simply be for brick and mortar. It may be for research and development. Okay, so a pharmaceutical company may spend many millions of dollars developing a cancer drug before they finally get to try it and finally get approval, hopefully, approval from the Food and Drug Administration. And so they have to recoup those sorts of things. So economies of scale in that sense are significant as well. We typically associate economies of scale with brick and mortar investment up front and so forth, but it's the same principle that applies when you have to develop any intellectual property as well. And that involves very significant research and development. Okay, so economies of scale, that's a lot of words there for one barrier to entry. Economies of scale because of huge fixed costs. That leads to a natural monopoly. In this situation, if the long-run average total cost curve keeps going out there and never goes back up, okay, at least on planet Earth, if we had a bigger planet, it might go back up. The market might be big enough so that it would go back up. But if for the size of the market, the long-run average total cost curve continues to decrease, then over time you're just going to have one supplier. You'll have what's called a natural monopoly over time. We see this in a lot of industries where the first mover or the biggest person in the industry starts to gobble up others, okay? Starts to buy out others. See this in restaurant chains and so forth. You see if two restaurant chains produce a similar product, kind of similar product, then the bigger chain may buy out the smaller chain over time. Okay, so let me go back. Network effects is another one. We talked about this last time a little bit. I got my iPhone here today just kind of as an example. Sometimes I think about how cool would this have been to have had this when I was in high school. But no, not really, right? Because I was in high school many years ago. If I'd have had this thing, there wouldn't have been anybody to talk to. And people would have said, well, what are you doing with that thing? So the point is, the value of this thing has increased as the network of users has increased. And so if you're, especially a first mover advantage applies here, if you're the first one to come up, to move from, to develop a certain kind of communication device. I'm just thinking back when they used to have pagers and so forth, don't have that stuff anymore, right? The first person who developed these sorts of things had a first mover advantage and so began to develop a network, and that becomes a monopoly over time. So we see this with computer software as well. Okay, I think of the whole Microsoft suite of things that work with Microsoft and so forth, and Google and so forth. So these are, if not monopolies, then kind of near monopolies, a duopoly or something in these industries, because they're strong network effects. Okay, legal barriers to entry like patents and licenses. We'll talk more about that later. But you may have this exclusive license to run that resort, or I guess it's a lodge on Yellowstone Lake. Have you ever been there? Beautiful lodge in Yellowstone Lake. Okay, not just anybody can go and say, hey, I'm going to put a lodge here on the beach at Yellowstone Lake. No, you can't do that. You got to have a license and all that. So that makes you the exclusive provider. And then there's other pricing and strategic barriers we'll talk about. So there's the natural monopoly case. So pure monopolist, it says here the pure monopolist is the industry. What we mean by this is that basically there's not this dichotomy as we had with perfect competition. Remember I drew two pictures with perfect competition? We had the market and the individual. We're only going to have one picture here. Okay, so the monopolist demand curve is the market demand curve. There's not two different demand curves. So the individual or monopolist demand curve is downward sloping because the market demand curve is. And because of that, very important distinction here, marginal revenue is less than price. Now they show this with a schedule here in your text. I want to skip over this for a moment and just go to the diagram. Then we'll go back and look at that, I think. But here is the monopolist demand curve. Now, the idea here is, recall, when you had a horizontal individual demand curve that applies to a to a supplier in perfect competition, we calculated marginal revenue by basically this blue area here. You had a horizontal line, and if you wanted to find the marginal cost, I'm sorry, I said marginal cost, marginal revenue, we're under the demand curve. Remember, if you want to compute the marginal revenue associated with a fourth unit, it was equal to the price. Y'all remember that discussion? You know what I'm talking about? Okay. Because the individual demand curve is horizontal, and so you don't have a red area like you have here. When you move from 3 to 4 units, you want to find the additional revenue on that fourth unit. Now here with a monopolist, if a monopolist wants to sell an additional unit in a period of time, so every month this monopolist sells 3,000 whatever. They work with units of 3. So you want to go from 3 to 4. Guess what? They have to lower their price a little bit. So here's the idea. You get this loss area. It's not just gain. Marginal revenue is not so easy to compute for a monopolist because you offset a portion of the gain with some loss. They have to lower their price. So for a monopolist to sell one additional unit in any period of time, they have to lower their price a little bit. Okay? It's not like the wheat farmer who can sell as much wheat as they want regardless. Okay? Whatever the price is, they're going to sell all their wheat or none of their wheat, half of their wheat at that price. Okay? However many bushels they take to market, that is to say, they'll sell at the same price. Not true for monopolists. Okay? Because this is not only the market demand curve, it's the individual demand curve. So what does that say then? It says that marginal revenue is diminished by the loss. So what's the marginal revenue here in this picture of the fourth unit? Can you tell? Can you read those numbers? Okay, well the gain is 132. That's it, but the loss is 30, right? So it offsets part of the 132. So the marginal revenue on the fourth unit is $102. Okay? Your revenue, remember revenue is a rectangle. And so this tall, kind of skinny rectangle changes shape. That revenue rectangle changes shape when you want to sell 4 units. It gets shorter, but it gets fatter. And if it just got fatter, then, I mean, that's the situation we had with perfect competition. But it gets shorter, okay, as well. And so the size of the rectangle changes by $102. So the marginal revenue, remember we use this ratio delta R over delta Q. We're just using delta Q as 1 here. Denominator is 1, but the delta revenue is $102. It's a difference in these. So here's the deal, 102. Now 102, I could plot it over here somewhere. You see it would be, I don't know if you see my arrow, but it'd be about, it'd be about 2/3 the way up to 132. Just imagine somewhere there. If I come over here and at the fourth unit, I put a point right there, it would be on the marginal revenue curve. Okay? So the marginal revenue curve is going to be below the demand curve anytime that individual demand curve is downward sloping. We're going to see this in other market structures as well. That's a very important thing. Okay? We'll be sketching that here and I'll just go ahead and go to this right here. This is really what the marginal revenue curve looks like in the top picture. I want to go to the, if I can, radar. I'm going to go to the dot cam here, and we'll just plot this out. Make sure this makes sense to us, okay? Show you what I'm talking about. We're going to come up with this marginal revenue curve you see at the top. So I'm just going to look here at the market for whatever it is, and this is a market for a monopolist. So let's just, Dr. J likes to draw in real time here. I don't know if that's really my best approach, but at any rate, let's just draw a bigger picture here and what's going on. So price times quantity, you got price going this way, you got quantity going this way. Now, we don't have this dichotomy, and it's just the market. That's all we care about. So and it's a downward sloping demand curve. Now, a couple things I want to mention here is that if the monopolist wants to go from 1 to 2 units of output to sell in the marketplace, total revenue is going to change because these rectangles inscribed by the demand curve changes shape. And because they change shape, they change size. So, this is what that picture illustrates here. Okay, that second unit is going to increase the total revenue rectangle by this amount. It's going to increase it by that, and then it's going to shrink it down by this amount. So remember, total revenue is what? Let's just put some numbers on this. This could be $200, and so this might be $195. But at any rate, the initial total revenue, TR for 1 unit, okay, TR for 1 unit, is the change in total is the price times the quantity. So it's P times Q. Let me do a capital Q. So this is 200 times 1, $200, okay? But now, what's the total revenue of 2 units? Okay? Well, price times quantity again, P times Q. In this case, it's 195 times 2. And that looks to be what? $390. So the total revenue has gone up by $190. So, that's the marginal revenue. The marginal revenue is the change in total revenue over the change in quantity. And so this is 390 minus 200 over 1. We're just increasing by 1 unit. And so total revenue here is $190. Okay, for the second unit. Now, think about that a second, and we could find 190 over here on this graph. Maybe it's right about here. It's saying that if this is the demand curve here, the marginal revenue is down here. This might be the price that we're going to charge for the second unit, but the revenue that comes in, I guess I better put it right here, the marginal revenue is $190. So marginal revenue is here. This is marginal revenue, but the price of the second unit is $195. Note this is less than $195, which is the price of the second unit. Okay? So the marginal revenue of the second unit is less than the price. Okay? Because, again, does that make sense? Oh, by the way, I realize this, and I will really try after class today. I'll scan these in and put them up to Dr. J's Chicken Scratch, okay? I meant to do that last time, and I got busy. I had to teach last night, so everything went on hold. I don't do that a whole lot, but I had to last night. Okay, all right, so marginal revenue is down here. So that's to say the price is on the demand curve, but the marginal revenue curve is going to be down here. It's going to look like this. It's going to be steeper, but it connects the same point, it turns out, but it's going to be steeper. Okay? Let's see how steep it really is. Okay? So this is because, again, the marginal revenue is less than the price on each unit. Okay? So here, there's a gain, G, and there's a loss here when you move from 1 unit to 2 units. But what if you're down here at a low price? Just a second. If you're at a low price. So it's the same picture. I'm going to draw the same picture here. But now my demand curve is, we're going to be down here. Okay? I won't put numbers on this, but I think you'll get the picture. I don't know. Maybe we're going from 99 units to 100 units. But at any rate. Okay, so if you lower the price now to pick up 1 more unit, whatever that is, you get a gain, but look at the loss. It's really big, right? So it turns out in this region here, and I'll draw it a little more particular in a minute, a little more specific, the marginal revenue turns out to be negative. Up here, at high prices, the marginal revenue is positive at high prices. Okay? In other words, I'm taking the vertical axis, the price axis, and I'm noting at high prices, okay, the marginal revenue is positive. If we go back, and I'm going to convince you with a picture in a minute, but if I split the demand curve in two and look at the top half, the marginal revenue is positive in this region because you have this situation here. If you want to sell one more unit, the marginal revenue associated with that unit is positive because the gain will exceed the loss. Down here, if you want to lower the price to pick up one more unit, guess what? The loss exceeds the gain. That'll happen beyond the midpoint right here. We've looked at linear demand curves before, okay? And we said way back there, this is early in the course, but we said that this is called the elastic region. In the price elastic region, the marginal revenue is positive. In the inelastic region, the marginal revenue is negative. Okay? All right, so remember how we did that, okay, for a linear demand curve. So here you got high prices, and so, you know, it's the elastic region here. You might go back and look at that. But at any rate, the point here is beyond the midpoint here, you get a reverse effect. Down here, it turns out that the marginal revenue will become negative. So that, if that's true, then the marginal revenue curve looks like this. Okay, this is marginal revenue. And this is the demand curve that gives you the price. If you look at the midpoint here and you come down to the axis here, the marginal revenue curve is going to become negative beyond this value of Q that splits these two intercepts. Now, okay, let me draw you a picture to convince you of this even more. Okay, and we'll go back and look at this picture on the PowerPoint here in a second. Okay, what are we saying here? Okay, let me draw right around the midpoint here, okay? And I think you'll begin to see what's happening here. Same supply and demand curve. Okay, so the idea here is that we're near the midpoint. Maybe we're selling a quantity that's just less than half of what we potentially could sell if we drop the price to zero. Notice we might be here, and you want to sell one more unit, which should take you to here. So, okay, so we're going to lower the price, P1 to P2. You're going to lower the price so that you can sell one more unit. Q1 will go to Q2. Does that make sense? All right. Do you see that when you're around the midpoint here, the gain equals the loss? Okay, so the marginal revenue around this quantity or this price has got to be close to zero. In fact, if it's right here, it's going to be zero. The marginal revenue, which is the change in total revenue divided by the change in quantity, has got a zero in the numerator. Okay, it's got a zero there because that rectangle doesn't change its area, changes its shape a little bit, but these are offsetting effects. Okay, so three things we've noted. Okay, this is the first one here. The marginal revenue is zero in this region right here for a middle Q or middle price. When you're talking a high price or low Q, it's positive. So again, in this region, the marginal revenue, or in these prices here, the marginal revenue is going to be positive. But down here, it's going to be negative. Marginal revenue greater than zero, marginal revenue less than zero. Marginal revenue is equal to zero right here. So if this is the demand curve that gives you the price of a good, then the marginal revenue curve looks like the demand curve, except it's twice as steep. Okay? So that over here, the marginal revenue is negative. For these prices, in this region here, the marginal revenue is going to be negative. So we're plotting two things on the vertical axis. We're plotting the price and we're plotting marginal revenue. We're plotting both of these, which is dollars per unit. That's the units, dollars per unit. So we're plotting two things here. The demand curve is the price. Okay, remember that's going to give you the price that you're going to charge at. And then the marginal revenue curve is also dollars per unit. All right, so let's go back to that PowerPoint slide a second. Let's just look at that, and you'll see what I'm talking about, okay? You're going to see the demand curve, which is also the individual demand curve. There in the top picture. You'll notice the marginal revenue curve is below it. For monopolists, and actually your other market structures as well, because they face downward sloping demand, individual demand curves. Perfect competition is the only one where the individual demand curve is horizontal. But you got marginal revenue less than the price. Okay? Marginal revenue less than the price. Now, so notice this thing here. This is an important curve as well. This is total revenue. So you got a different vertical axis here in this sketch at the bottom. You got quantity. The horizontals are the same. Those are Q. We're plotting total revenue on the vertical axis here. And what this is, on the vertical axis in the second picture, is giving you the area of these rectangles we were plotting. Because total revenue is area. So up here you got price. So when the price is high, okay, and you lower the price, remember when the price is high and you lower the price, the rectangles get a little shorter but fatter. They grow in area. Remember that? I don't know, but that was, if you look at the picture, we probably got it brought back here. Let's go back here. When your price is high, the blue is bigger than the red. So the rectangles get bigger. Total revenue goes up. So you got a high price, you lower the price a little bit, revenue is going to go up. That's what this is showing down here. And in the left part of that parabola, okay, if you increase the quantity by lowering the price, that's the only way you can do it. Law of demand. Notice the curve goes up because what are we plotting on the vertical axis here? We're plotting the size of those total revenue rectangles. And when you get around about the midpoint, now notice something here. Now this is just kind of, it's usually pretty close here. Notice at almost 18 units, the total revenue is going to be 0. And so the idea is to sell 18 units, you got to lower your price down to pennies. Okay? Your revenue is going to be 0. Okay? So your total revenue is 0 here. But notice halfway between the minimum quantity you could sell and the maximum quantity you could sell. Notice that, I'm going to turn that off. My phone is buzzing here. Sorry about that. About halfway over, notice here that the total revenue is going to be a maximum. Okay? Going to be a maximum. What's that saying? It's between the two possible quantities, bookends, that you might sell by varying the price. The rectangles are going to be their largest at the midpoint. Okay? So, you know, what is that? That looks to be about 9 units here. Whatever price that you can charge and earn 9 units, or sell 9 units, is going to give you a maximum total revenue. So in that mid region, the rectangles are the biggest. Now if you lower the price below that to sell more units, if you want to get up to about 18 units, 16, 17, 18 units to sell, the price has got to be so low that the total revenue is driven back down to 0. So what kind of rectangles you got there? If we were to draw this picture again, that's kind of the situation, okay? Is you got these short, fat rectangles, and they essentially become 0 in size. All right, so this is critical. Now here's where we're going with this. Why is this so important? Is because since we've got the dot cam here, I'm going to stay right there with it a second. You have these two curves now for monopolist. You have demand, looks like this, and you have marginal revenue, which I'm saying splits this distance. If this is 18, this is about 9. Those were the numbers we were looking at. And so the marginal revenue is about here. All right, marginal revenue. and this is demand, which gives you the price. Okay, now, remember I said last time and the time before and so forth, ever since chapter 9, in the short run, you also have these U-shaped cost curves. Guess what? They don't change. You still have the same, the cost side of production is not affected by the demand side of the market. Okay, so you have these curves like we've had before. You have average total cost curve and marginal cost curve and so forth. So I want to draw a average total cost curve on here. And through the minimum of the average total cost curve is a what curve? Marginal cost. Okay? So those are two curves we've looked at before. This curve goes through the minimum of the average total cost. Both of these explode on the right because we're talking about the short run. You get diminishing returns to the variable input. If it's labor or what have you. If you're going to drive up the quantity, you got to hire more workers. You pack more workers in the same size factory. You're going to drive up average cost of output and also marginal cost of output. So this is a picture here. We've added two curves, but these two here, for the moment, are very important to us in our study of monopoly. These are the same cost curves we've had before. What I want us to see here is that the rule, the profit maximizing supplier, so in this case it's a profit maximizing monopolist, is going to do the following. They will equate marginal revenue with marginal cost. Remember I said if you're going to tattoo a rule on your body from economic theory, this is the one. Now I didn't write price equals marginal revenue or anything here, or marginal cost. In perfect competition I can put price on the left because price and marginal revenue are the same. But that's not true here. Price and marginal revenue are different in monopoly. So I write this. This is true in any market structure. You produce one more unit, if you think on the margin, you produce one more unit if the marginal revenue exceeds the marginal cost. So if I'm producing over here somewhere, say right here, notice marginal revenue is this curve, right? Marginal revenue is, say, up here. Marginal cost is down here. I'm underproducing. Okay. If I'm over here at the extreme where it's easier to see, this is the marginal cost curve up here, and this is marginal revenue down here. Marginal cost exceeds marginal revenue. I'm overproducing. That means the last unit I produced came at a higher cost than it added to my total revenue. This is the quantity I want to produce at, Q star. Notice at this level of output, marginal revenue equals marginal cost, okay? Those two are equal. Here, I'll put marginal revenue again. So this will tell me the quantity I want to produce at. The price I want to charge is found by the demand curve. So I extend this on up, and then I come over here, and this is going to give me the price. I'll call this P star. Okay? So, you know, I look for marginal revenue equals marginal cost. That tells me the quantity. I look up to the demand curve. That's going to tell me the price. So price times quantity. This will give me total revenue right here. Total revenue is that rectangle. Remember, it's just, if you took the cost curves off, you just got another one of these rectangles that's inscribed within a demand curve like we did these rectangles here. Okay? So this is total revenue. Guess what? Total cost is the average total cost times the number of units you sell. So the total cost is this rectangle. So notice I look here at the total cost, average total cost of Q2 units, and I'm going to come over here. Okay, so I look at this curve, multiply the average total cost times the number of units, gives you the total cost. Does that make sense? If I said the average age here is 30, it's not that high. Well, I mean, it's because of me. The average age is 30, and there's 10 of us. What's the total age? You multiply the two. You multiply the average by the quantity. So this gives you total cost. This is total cost here. The big rectangle is total revenue. Guess what this is right here? That's exactly right. That's profit. Exactly right. It's profit. It's what's left over out of revenue when you take out cost. Okay? So you got profit here. Now, so you have an economic profit here. Now, what's the implication here? This is a long-run situation in monopoly. Remember, long-run in perfect competition, the market, profits, what happened to profits in the long run in perfect competition? They get competed away, right? Because there's no barriers to entry. The profits evaporate. Okay, so we had this picture before, if you go back and look at it, and I'll just allude to it real quick, just to make sure we remember this, but we had this long-run situation for a monopoly, for a perfect competition. Let's see here. Well, here's one. We moved off of it, but remember this right here. You remember? You're going to have zero profits here. You might go back and look at that, and then if something perturbs that market, you might create a profit. But here, in the long run, under monopoly, you'll have a profit, an economic profit, which means other people want to get into this. Other people who own capital want to, build that lodge on Yellowstone Lake. They want to, but they can't. Why? Because there's barriers to entry. So this profit right here is sustainable in the long run, okay? Sustainable in the long run. Why? Because there are some kind of barriers to entry. One of those that we just looked at, economies of scale. I mean, Walmart's going to make profit for a long time because, it takes a lot of stuff to get started. They're not a monopoly, but you might think of them as a near monopoly. Airline manufacturer, commercial aircraft manufacturers is a duopoly for the most part. You've got Airbus and Boeing, so forth. Okay, so these profits are sustainable in the long run. Now notice that as far as the market goes and where you have these efficiencies we've looked at before, that is to say, price and marginal cost are the same here. Remember that? Look, we looked at that. This is where, if it were a perfectly competitive market, this is where the market would exist in the long run. It would be right here. Okay, so at this level here, price is equal to marginal cost. P equals marginal cost. Remember what you have there is called allocative efficiency. Remember that? If price equals marginal cost, we looked at this before with perfect competition, the market, in the perfect competition, you're going to wind up here. You're going to have allocative efficiency. You're also going to have productive efficiency because price is going to equal minimum average total cost. So there's a couple things going on. The market demand curve actually shifts and so forth so that this point actually moves to right here. Well, the first thing I want us to see, though, is that you're not going to have any efficiencies that we typically associate with perfect competition, like you're not going to have allocative efficiency. Price is not equal to marginal cost. In fact, it's going to be greater than marginal cost because the monopolist can do this. They can raise their price and sell fewer units than what the market would like. All right, as far as the demand side of the market, there's not enough stuff. There's not enough insulin if there's only one maker of insulin. There's not enough Cipro if there's only one maker of Cipro. There's not enough electricity if there's only one firm that delivers electricity to your house. They're going to charge a little bit more. Now it gets a little more complicated with utilities we'll look at in a minute. But monopolists in general will charge a higher price and bring fewer units to the market. Why do they do that? Because they want to satisfy this condition here. That's the condition that will maximize profit. That's what you want to do. I mean, that's a rational supplier in a capitalistic society is one who wants to maximize profit. Okay? If you know of anyone who says they're making too much money, let me know. I want to meet that person. Okay? I want to work for that person, maybe. What have you. Okay, so this is the situation in the long run for perfect let's go back now to the PowerPoint here. For pure monopoly, that's what you have. So you have a slide here I've given you. Well, I've borrowed some of these. I kind of did my own, but I borrowed a little bit here. And this is a graph I borrowed out of your book. It's basically the same picture. They've just got some numbers on it. Okay, so they give you this little, I think here, 3 steps that you want to go through to find the profit maximizing price and output for a monopolist. Step 1, determine the profit maximizing output by finding where marginal revenue equals marginal cost. So that's what we did here. And this looks to be at 5 units in the numbers they give you there in your book. It looks to be at 5 units. Okay. Second, determine the profit maximizing price by extending a vertical line upward from the output determined in step 1 to the pure monopolist demand curve. So you always look up at the demand curve to see the price you're going to charge. So you extend, remember I did this with the picture, but you extend this line all the way up here to the demand curve. And that's going to tell you the price. Step 3, you can determine the pure monopolist economic profit by using one of the 2 methods. Essentially what we're going to do here is find the area of this green rectangle. So they give you these 2 methods. Say find the profit per unit by subtracting the average total cost of the profit maximizing output from the profit maximizing price, then multiply the difference by the profit maximizing output to determine the economic profit. Okay, whew, that's a lot of words, but that's what we did here. We found this distance here, okay, and then you multiply by Q. I'll give you this. Or what they'll tell you is find the total revenue, which is the big rectangle, and subtract the little rectangle. I guess that's kind of what we do. You do it either way, okay? Do it either way. Now, let me ask you, do you see a couple of things here? First off, take this picture here. What if in reverse, leave the cost curves where they are. In reverse, you want to describe the demand side of the market. And I say in reverse by drawing the marginal cost curve first. I'm sorry, marginal revenue. I said marginal. Draw the marginal revenue first, and then draw the demand curve. Okay? Well, the demand curve, I mean, the marginal revenue is twice as steep. And they kind of both come together. They marry up on the vertical axis. Okay? Well, here's what I want you to think about in a second. What if I start with the marginal revenue and drew the demand curve? But first I did this. I made the marginal revenue curve steeper. Can you see that? So instead of it looking like this, it was a lot steeper. What would happen to the location of the demand curve? Can you see? This is a very important point. I don't know if I'm communicating. So here we go. We'll go here. I want to draw 2 pictures just to drive this home. Okay, so what I'm saying here is that let's start with the marginal revenue curve. All right, so here's a marginal revenue curve. Okay, and then I'm going to draw a steeper marginal revenue curve. Now, the demand curve is half as steep as the marginal revenue, right? So in this case, the demand curve comes all the way out here. In this case, the demand curve just comes here. Am I making sense? You see that? Because we're doing things in a reverse direction. A while ago, we started with the demand and we sketched this. Now I'm saying draw the marginal revenue curve, but make this one over here twice as steep as this one. What are the corresponding demand curves as this? Now here's the deal, okay? If I just slap the same marginal cost curve on both of these, this curve is the same as this curve. They're the same curve. What's the difference here? the prices I'm going to charge will be different, won't they? Okay. It could be this price here is higher than this price. I don't know how convincing my picture is. But the price here could be higher than the price here because the demand curve is steeper. Okay. In other words, okay, it might. Okay, you're going to have a thinner but taller profit rectangle, aren't you? That's right. So depending, it's going to have a different shape to it. That's for sure. But notice here, the marginal revenues could be the same, and I could play different games here. Actually, what I was thinking is let's just add one more thing to this. I don't mean to muddy the waters, just kind of draw this principle a little bit more. Really, I'm trying to... Let's do this, make this change to the marginal revenue. So the marginal revenue is here, okay, where it intersects marginal cost. I'm going to have the same marginal revenue over here. But now my marginal revenue curve is going to be significantly steeper. Okay, I'm going to go through this same point. I'm just going to take this a little distance here, but I'm going to make the marginal revenue curve look like this. Same marginal cost curve. And I probably should have drawn this first. Okay, so I got the same marginal cost here. I got the same value for the marginal revenue. Same value for the marginal revenue. It's not the same marginal revenue curve, but it's the same value. Okay, so these two are the same, and those are the same curves. If that's the case, then the demand curve's way up here, right? Demand is way up here. Now notice, always equate marginal revenue and marginal cost. So this is the optimal level of output. But up here, or I guess I should say on the right, it's obvious here you charge a much higher price. So I equate marginal revenue with marginal cost. Okay, so I have the same marginal revenue and the same marginal cost curve, so that produces the same Q star. But I want to charge a higher price here than here. Okay? So if you think about it, it's something to meditate upon just a little bit. This curve serves a different function than it did for perfect competition. In perfect competition, we said the marginal cost curve was the individual supply curve because it gave a relationship between quantity and price. Quantity supplied in price. The quantity that a supplier will bring to the market, you can always measure this way, but it's going to be delivered to the market at differing prices or lower prices here than here. I don't know, it might be a little abstract. I probably left you there, and that's okay. Something to think about. The marginal cost curve here is no longer an individual supply curve. Okay, it's no longer an individual supply curve. I feel like I was a little bit messy there. But as it was in perfect competition, okay, you don't have a supply curve in monopoly. You don't. There's not a single curve that relates price to the quantity supplied. At this price, you know, this is the quantity supplied, but if we adjust the marginal revenue a little bit but have the same marginal revenue value, then the same quantity is supplied at a higher price. So there's not a unique relationship, if you will, between price and quantity supplied. Might be worth thinking about. This might be reaching a little much for us this morning, having introduced all these topics. Okay, let's go back to the slides here. Okay. Yes, yeah, Glenn. There is really no supply curve in monopoly, okay? A supply curve, think about what is a supply curve. It tells you, it's a rule that tells you what quantity supplied for each price, right? Okay. And so, well, you don't have that with monopolists, because you got to put in the demand side of the information before you got a rule between price and quantity supplied. Okay? Does that make sense? Because the way we drew that demand curve puts you at a higher price for the same quantity supplied in that second picture. There's not a single rule, there's not a curve, one curve that tells you the quantity supplied for each price. You got to have additional information in monopoly. Okay, we can talk about it some more, but that perhaps is the more abstract concept there. Okay, now does a monopolist have to earn a profit? Nope. You might have a loss. Look at that. So what have we done here? We've sketched this second picture from the first, which is up here, by simply shifting the cost curves up. The demand and marginal revenue are the same. If you go back down here, it's the same. You could leave those in place. But if you move those U-shaped curves, those cost curves up, and they've got the AVC curve here as well, guess what? It could be that at the optimal quantity of production, that the average total cost could exceed the price. Okay, so how do you determine the monopoly price? That's that P sub M on the left, and that's the extended from the demand curve. Okay, so you just move over here. So if the average cost for a unit exceeds the price the monopolist is going to charge, that means they're earning a negative profit on each unit, right? So in total, there's negative profits. There's a loss. So it depends on the position of this. Now, that's not sustainable, not in the long run. You'd want to get out, right? So if you have positive profits, firms are going to want to come in, but at least they can't for a while as long as you got the patent or something like that. Something that keeps that barrier to entry up. You might be able to chip away at it. Your book talks a lot about how to chip away at barriers to entry. But if you got a loss, you're going to want to get out as soon as you can, okay? At least this is not a sustainable situation. You might be able to drive those cost curves down. If you can drive those cost curves down, lower those U-shaped curves there, then you can begin to create a profit. Now, let me ask you, what's going to happen when you just begin to break even? Do you see that, the red curve, the average total cost curve, is going to just brush that. Actually, it intersects the demand curve right there at this value, so that you squeeze that profit, well, in this case it's a loss, down to zero. So if the cost curves are above the demand curve, you're going to have a loss. If the cost curves are below the demand curve, you're going to have a profit. They worked through some numbers there and so forth here. Let's go back to the profit situation again here just a second. Okay, remember I said, and I drew the picture here, that in perfect competition, this would be the supply curve. Where supply and demand intersect is where the market's going to want to be in perfect competition. There's no patents, there's no barriers to entry, there's a standardized product and all this. But with monopoly, you raise the price and you lower the quantity you sell to maximize your profits. There's a couple things that's going to happen here. I hope you see this on the right. First off, consumer surplus is without a doubt diminished. Do you remember consumer surplus is the area below the demand curve, the price that people are willing and able to pay, the area below the demand curve and above the price. Do you see that this big triangle here, P, C, and then P sub C, okay, shrinks to P, B, P sub M. Okay, because the price goes up. The monopolist is going to raise the price. So consumer surplus diminishes without question. Producer surplus probably enlarges, but that's not necessarily always the case. Notice that producer surplus is the area below the price and above the supply curve. And this is a supply curve in perfect competition. Okay? But at any rate, we're going to raise the price and shrink the number of units. So the producer surplus triangle becomes this trapezoid here. You lose some area. I don't know if that cursor is visible or not. That bottom gray rectangle, the bottom one, the producers lose that to pick up this rectangle here. That rectangle there is a transference of surplus from the consumer to the producer. Okay, thank you. Okay, so there's fewer units sold. That's bad news for the producer. However, they're charging a higher price on the units they do sell. That's good news. So if they're maximizing output, you would maximizing profit, you would expect this rectangle to have a larger area, which is what they pick up in the way of their profit. That's going to have a larger area than this little gray rectangle, the little gray rectangle that they lose from selling fewer units. I hope that makes sense. I could draw that out as well, I guess. But at any rate, I hope this makes sense, okay? Have I lost anybody today? I've gotten kind of abstract, right? Are we good? Okay. I think, I might have overdid it here a little bit with the marginal revenue curve, but just to justify, and they do it in words. They don't do a picture in your book, but they just basically tell you in words. There's no supply curve in pure monopoly, and they kind of tell you in words what we did there on the diagram. Okay, all right, okay. So now the last thing I want to say about this picture is there's an efficiency loss. Okay, remember two types of efficiencies we talked about in perfect competition. First off, there was allocative efficiency, which you get when price equals marginal cost. Remember that? I drew this equality, price equals marginal cost equals minimum average total cost. Price equals marginal cost in perfect competition. That means because of that, we're allocating resources across the economy in the way that we should. If price equals marginal cost, that means the last unit sold was sold at a price that it cost to produce. So someone values that last unit at the same price that or cost that it took to make it. Okay, all right, so there's nobody saying, I wish I could buy, another lawnmower here, and there aren't any lawnmowers here. I got $200, and everybody else got one for $200, and I got left out. You don't have that situation. So, and you're allocating just the right amount of resources toward the production of lawnmowers, or whatever it is. You don't have that situation here. The price is up here at P sub M. Marginal cost is down here at P sub C. Price exceeds marginal cost for monopoly. Therefore, you have no allocative efficiencies. So we're actually since we're underproducing the unit in the product market, we're under allocating resources to the production of that good in the resource market. Okay, hope that makes sense. So there's no allocative efficiencies. Now, depending on where the average total cost curve is, you could be producing at minimum average total cost. So you might have productive efficiency, but that's not likely as well. It's not likely, but it could happen. In perfect competition, remember, you will always gravitate to those two types of efficiencies. That picture we had for perfect competition in the long run showed us that you have both allocative and productive efficiencies. But you certainly will not have allocative efficiency here for a monopolist. Just want you to see that. So, but why? Again, there's too few units being produced. Because there's too few units being produced, there's too few resources being devoted to the production of this good. You're allocating too few resources. Okay, so we're going to get into this next time. We don't have time today, but we're going to talk more about the economic effects of monopoly. Just to mention here, some of these we've talked about, but you see the word inefficiency down there, the fourth one down, and so forth. That's just one of those things that X inefficiency, not a big deal, but I want you to read over these topics for Thursday. But let's just go back here. You know, there's the income transfer and so forth that we just talked about here, with, going from producers to consumers. But they had this little table here, right here, that's in your book. And this is, I want you to see here that this is a monopolist. We can recognize that right away here from the first two columns. If you want to sell more output, you got to lower your price. Okay? Got to lower your price. Now, when we did a schedule like this for perfect competition, these prices were all the same. The individual supplier is charging the same price because it's a horizontal demand curve, individual demand curve. Now, notice some things that result from that. The marginal revenue also decreases, but decreases at a faster rate. So the marginal revenue here, okay, on the first unit, which is a change in the total revenue, divided by the change in the price. You got to take the total revenue here, change in quantity. The change in the total revenue is $162. You divide that by 1 unit. So the marginal revenue on the first unit is $162. Here it's $142. Notice it's always less than the price. If you run these numbers, you'll see that the marginal revenue is always less than the price. Okay? So 42 is much less than 112, so forth. So marginal revenue is less than the price. So that curve is beneath the demand curve. But you want to produce at a level where marginal revenue and marginal cost are the same. And I think they've got that kind of here. You see those numbers that are blocked in? I guess maybe I should move my cursor over here. Is my cursor visible on the screen there? Okay, now it is. I was on the wrong screen. I'm sorry. Notice here, marginal revenue is 82. Marginal cost is 70. When you go from around the 5th unit, the marginal revenue goes down from 82 to 62. Marginal cost goes up from 70 to 80. So somewhere in this region, if you could sell half of a unit or a third of a unit or a partial amount of a unit, marginal revenue would equal marginal cost. So that's why this is blocked in. This gives you maximum profit. So you go over here to the right, and you'll see that this number is the biggest it can be. Profit is the largest when you get marginal revenue, which is over here, between these two numbers. So it's around the 5th unit equal to marginal cost. So I want you to study that, okay? You'll have a homework problem or two where you'll need to fill the table out. They'll give you some of this information, and then you'll fill the columns out, and then you determine what level to produce at. Now my intent is before I lay my head on the pillow tonight, your homework for this chapter will be up, okay? And we have our second exam in this class a week from tomorrow. And so I'll probably leave it open through the weekend. And, you know, I think we'll be okay here as far as including this chapter on that exam. And what I'll probably do, I plan to do too tomorrow, is go ahead and remember how I put some review exercises, optional thing. But that, I hope that helped you on exam 1, okay? Because I went back, I put the same problems, just changed the numbers on the vast majority of the exam. I'll do that again on this exam, okay? So I'll be putting some of that up tomorrow. It gives you a week to get ready for this exam. Now, we will come back on Tuesday next week and wrap up this chapter. We looked at the conceptual stuff today, so I think as far as drawing pictures and all that, you got that. Read through the chapter. Be sure and read through the chapter, and we'll wrap it up, answer any questions you might have on Tuesday. And then we still got another bite at the apple on Thursday next week. If you got any questions about Unit 2, I can address those. I'm also available to confer with you on Zoom and so forth, so let me know if you want to do that. And then you should be in good shape for the exam a week from tomorrow. probably the following Saturday. Okay, well, y'all have a good day, and I hope I didn't bore you too much today. This is a little technical, and I'll see you next time, okay?